So the Pythagoras theorem again is this relationship between the three areas of the right triangle. Now this only works for right triangles. Okay, if we change the angle in here, this does not work. Okay, but if it's a right triangle, the square off of the short side here and the square off of the other short side, together these areas, these squares, add up to the square off the diagonal, or a squared plus b squared equals c squared. And again, it's important to know that this is not about adding the lengths. We're relating the three areas, not the three lengths together. So we can do problems here using this Pythagoras theorem. So let's draw a picture. So this here has a 2-meter long ladder. It leans against the wall, and the bottom of the ladder is 0.5 meters from the base of the wall. How high up the wall does the ladder reach? So here's my wall, there's my ground. Okay, I'm going to have a 2-meter long ladder, and it's 0.5 meters from the wall. So that's the distance from the wall to here. And we're going to assume that that's a right angle. So we want to know the height along the wall that we're going to reach. Okay, well, here we've got our right triangle. We know that the square off of h, the square off of 0.5 should add up to the square off of 2 meters. Okay, so it looks like this: h squared plus 0.5 squared, again it's about the squares, not about the lengths, is equal to 2 squared. Okay, again it's about the squares. So h squared is equal to 4 minus 0.5 squared is 0.25. So the height squared is equal to 3.75. That's going to be the square off of that edge. Okay, so if I want to find out the length of that edge, then I need to go from, I've got the area, I need to square root. So 3.75 by square root 3.75, I get 1.94. So h is equal to the square root of 3.475, and I get the height is equal to 1.94 approximately meters. Okay, and that sounds about right. My ladder's 2 meters, not going to reach quite 2 meters up the wall. Okay, so let's take a look at this one here. So Susan's gonna walk 3 kilometers north, 3 kilometers east, and then 1 kilometer up. So I'm gonna say that she starts at the origin, and let's make 3 kilometers north. Let's go make each square 2 squares 1 kilometer. So there's 3 kilometers. 3 kilometers north. Okay, so and then 3 kilometers east. So 1 kilometer, 2 kilometers, 3 kilometers east. Okay, so this is my path. It goes like that. Goes 3 across like this, and then 1 kilometer north like that. Okay, and we want to know how far she is from the starting point. So we need to know the length of this line from there to there. Okay, well I have 2 right triangles here. And I know there's a Pythagorean relationship, so I know that 9 squared plus whatever this square is. Oh, the problem is I don't exactly know where that's going to be, where to cut that off. And I don't know this line here, so I just know that this whole line is 3, but I don't exactly know where along this line I should chop it up. Okay, so we've got a bit of a problem here. Now, I don't really need to know these little bits here, and chop up the red bit into 2 parts here. I just need to know how long that whole red line is. So what I'm going to do is this. I'm just going to make one big right triangle where the red line represents the hypotenuse. So here I've got 3, so I'm going to have 3 by 3. So this is going to be my 3 by 3 square here. This one goes 3 up and then 1 more up, so it's going to be a 4 by 4. Okay, so it's going to be 16 here, and that's going to give me the diagonal square area. Okay, I'm just going to kind of sketch it in the diagonal square area. This is going to be 25 squares. Well, if I want to find the starting point, then the distance squared is equal to 25. So the distance is going to be, go from area to side length, I'm going to square root. So there it is. The distance is 5. So we are 5 kilometers from the starting point.